Welcome back. So in this video, we are going to see the next program design tool, which is called Flowchart. So this particular design tool, again, you will be using in different stages of programming. Even if you become a high level programmer, you will be always using some kind of diagrammatic representation for representing your program or software. So there are different types of diagrams as you move from this semester 1 to your higher semesters. You will be learning different types of diagrammatic representation of how to solve your problem and develop a software. So flowchart is a very basic representation, and we call that as a program design tool. So flowchart is a diagrammatic representation of an algorithm. Very simply, if you want to say what is a flowchart, again flowchart is a diagrammatic step-by-step instruction. So it is flowchart is going to be, it is a diagrammatic explanation of, diagrammatic representation of the step-by-step procedure. Explanation of the step-by-step procedure to solve the problem. Okay. Again, we are going to represent a solution, but now our aim is to show that as a diagram. Okay. So flowchart is a diagrammatic representation. So it is going to be a diagrammatic representation of the algorithm or the step-by-step way in which you are going to solve a problem. So we are having different symbols in a flowchart. So first and foremost is we should understand the different symbols. So normally even a hexagon or a rounded rectangle or a oval kind of symbol is used to represent start as well as end of the procedure or the algorithm. To represent the start and end, or to signify the start and end, either you can use an oval shape, rounded rectangle shape, and then to represent reading an input or printing the input, you go for a parallelogram symbol. So this is to read a value or to print a value. So this is for input and output. So it's like a parallelogram. And to show the process, to explain the step-by-step process or some computation, mathematical computation, some assignments, to do all these things, you use a rectangle shape, okay, to do some process or computation. We go for a rectangle symbol. Apart from this, to test a condition, to repeat for a particular, where till the condition is satisfied, you have a decision symbol. Okay, so this symbol you call it as a decision symbol, okay, which is like a rhombus. Okay, so decision symbol. So this is to make decisions. So it will have at least two branches. Most of the cases it will have two branches, yes or no, based on the condition. So based on the decision or the condition what you take here, either you will be having an S branch or you will be having a no branch out of it. Okay. So always you should label the branches. So whenever you draw a flowchart, you should label the branches as yes or no. So this is very important, labeling the branches. So this decisions, the same box is used for conditional constructs, that is to compare values, and even for repetition we are going to use the same symbols. Finally, you have a very small circle kind of symbol. So this is used for as connectors. So whenever you have a very large problem and you have a very complex flowchart which runs to pages, or you are going to make the diagram parallelly. So we are going to cut in one place, start in another place. In such cases, you can continue, like you can have a circle here, you can appropriately label it, and in somewhere else where you are having a place, you can start it like this. It means that the flow, what you terminated here is starting here. Okay, so this type of symbol, to represent that, you have a small circle, and this you call it as connector. Okay, so you're going to see the same example for flowchart as linear search. So algorithm also we were discussing linear search. So flowchart also we are going to discuss linear search. So the first symbol is dot. Okay, so I'll take it as a rounded rectangle. Start. The second step is input. What are all the inputs? So we have a set of input. What are they? The number of elements in the list. So we are going to read the number of elements in the list, and you're going to read every element in the list and you're going to put it in A. And finally we are going to get one more input, that is a search key, the element which you're going to search. So N is the number of elements in the list, total number of elements in the list. A is the list itself, which has index from 1 to N. And K is the search key. You need not explain all this, just for understanding purpose, I'm just representing it. And next is you're going to make assignments or initialization. So I'm going to have a rectangle. So I'm going to assign an index variable. I'm going to set it to 1 because that index will start from 1 to and move till n. So I'm going to set it to 1. And I'm going to have another variable which is I'm going to use as a flag to check whether the element is found or not. So initially I'm going to assign it to -1, and till the end of the loop, if it is remaining -1, it means that the element is not found. Okay. So next is I'm going to go for a condition, that is decision making symbol. Okay, so what is the decision? Whether your I is less than or equal to capital N. Your I is less than or equal to capital N. So initially it is 1. So N will be some 5 or 6 or whatever based on the example. So if it is no, it is not lesser, you have a branch, and if it is lesser, you have another branch. So you just label it. Immediately you just label it. If it is less than or equal to N, what does it mean? It means you have still more elements to process or compare. Okay, so in the first iteration, this will be 1. And naturally 1 is less than or equal to n, the size of the array, and in which case what you have to do is again you have to go for a comparison. That comparison is to check whether the element in the position I is equal to k. The element in position I is equal to k. And when you compare this, again you have branches. Okay, you have a S branch. Okay, the element is equal. Okay, and you have a no branch. So this time I'll have the no branch this side. So now what you are supposed to do, no? If it is yes, which means we have found the element. Okay, so this is the case where you have found the element. This is the case where the element is not matched, and till now we have not found it. Till this point we have not found it. So what we have to do if we have not found that is if this particular array element at ith position is not equal to k. What I should do? I should repeat the loop. Okay, I should increment I by 1 and I should repeat this loop. So I just go here. So this is loop. Okay, so I am going to loop or I am going to repeat. Okay, for the next I value. Okay. And if it is found, okay, if it is found, now what I am going to do is the very important thing I should do is the position should be set to I. Position should be set to I. And I am just going to print that I have found the element. So print the element is found. Okay. But there is a case where you move to all the elements and finally you come to a case where I is equal to or greater than n. Okay, I is greater than n. So 6 elements are there in the array list, but 6 elements are not matched. And when you are coming to the 7th element, this condition will fail. Okay, this condition will fail because I is 7 and n is equal to 6. So this condition will fail, and in this case you have to say that at the end of it I have not found the element. Print not found. Okay. So in both the cases, both the loops has to come to, so I'll just use this connection also, so that, okay, so both the points will go to the same point. Okay, so same point A, and A is going to go to a condition called M. Okay, so I have used a connector also. Since we have come to an end, so this branch also should come to an end. So this branch also should come to an end. So which I have just added with the help of a connector. So this is a connector. Okay, hope you have understood it. Thank you.